Imagine discovering an entire civilization buried beneath your feet, hidden for centuries, only to be revealed by the blink of a laser beam. Welcome to the future of archaeology, where cutting-edge technology is unearthing secrets of the past in ways that were once deemed impossible. Today we dive into the astonishing technological advances that are revolutionizing archaeological research and transforming our understanding of history. For centuries, archaeologists relied on manual digging, rudiment tools, and sheer luck to uncover historical treasures. While these methods yielded significant discoveries, they were often slow, labor-intensive, and sometimes damaging to fragile artifacts. The dawn of the digital age has brought a seismic shift in how we explore our ancient past. One of the most groundbreaking technologies in archaeology today is LiDAR, which stands for light detection and ranging. This remote sensing method uses laser light to measure distances to the Earth's surface, producing precise three-dimensional information about the shape of the Earth and its surface characteristics. Imagine flying over dense jungles or rugged terrain where traditional methods would be near impossible, and in a matter of hours, revealing the hidden layouts of ancient cities and roadways. This technology has unveiled vast networks of Mayan cities in Guatemala and provided new insights into the Angkor complex in Cambodia. LiDAR's ability to penetrate dense forest canopies has made it invaluable in regions like Central America and Southeast Asia, where thick vegetation conceals ancient ruins. By stripping away the layers of greenery in digital models, researchers can study the underlying topography and uncover previously unknown structures, pathways, and agricultural terraces. This has led to a dramatic increase in the number of known archaeological sites, providing a more comprehensive understanding of past civilizations and their interactions with the environment. Another transformative technology in archaeological research is ground-penetrating radar, GPR. GPR sends electromagnetic waves into the ground and records the signals that bounce back from underground structures. This non-invasive method allows archaeologists to create detailed maps of buried features without disturbing the soil. GPR has been instrumental in locating unmarked graves, hidden chambers, and even entire buildings buried beneath layers of earth. One of the most famous applications of GPR was the discovery of a hidden chamber within the Great Pyramid of Giza, a find that has reignited interest in the mysteries of ancient Egypt. But the technological revolution in archaeology doesn't stop there. Satellite imagery and aerial drones have become indispensable tools for modern researchers. High-resolution images captured from space or low-flying drones provide a bird's-eye view of archaeological sites, revealing patterns and structures that are often invisible from the ground. These aerial perspectives have led to the discovery of large-scale geoglyphs, ancient irrigation systems, and previously unknown settlements. In Peru, for instance, drones equipped with multispectral cameras have been used to uncover new Nazca lines, the famous ancient geoglyphs etched into the desert floor. In addition to revealing new sites, satellite and drone technologies help monitor and protect existing ones. They allow archaeologists to track changes over time, detect signs of looting, and assess the impact of natural disasters. This real-time monitoring is crucial for the preservation of cultural heritage in regions prone to conflict or environmental threats. 3D scanning and photogrammetry have also revolutionized the way archaeologists document and share their findings. These technologies create detailed, high-resolution digital models of artifacts, structures, and entire sites. By capturing objects and sites in 3 dimensions, researchers can study them from any angle, conduct virtual excavations, and even create accurate replicas. These digital models are invaluable for educational purposes, allowing students and the public to explore archaeological sites from anywhere in the world. They also facilitate international collaboration, enabling researchers to share their discoveries with colleagues across the globe. Moreover, 3D printing technology is being used to recreate artifacts and structures with astonishing accuracy. These replicas are not only used for display in museums but also serve as important tools for research and conservation. For instance, if an artifact is too fragile to be handled, a 3D printed replica can be studied instead, preserving the original while still allowing for detailed analysis. DNA analysis has opened up new frontiers in understanding ancient populations and their movements. By extracting and analyzing DNA from ancient remains, scientists can trace genetic lineages, study population dynamics, and uncover connections between distant cultures. This molecular approach has led to surprising discoveries, such as the realization that early humans interbred with Neanderthals and other archaic hominins. It has also shed light on the role of artificial intelligence, AI, in understanding the migration patterns of ancient peoples, offering new perspectives into how early human communities spread across continents and interacted with one another. These migration patterns, once deciphered only through manual excavation and dated artifacts, are now being re-examined through the lens of cutting-edge technology. With the help of AI, scientists can now cross-reference genetic data, ancient tools, environmental conditions, and historical records to map out complex migratory paths that were previously difficult to trace. This has not only expanded our knowledge of early human movements but also revealed how cultures evolved as they came into contact with one another through trade, war, or shared innovations. In recent years, another groundbreaking technique that has significantly contributed to archaeological research is stable isotope analysis. This method has emerged as a powerful tool for reconstructing ancient diets and understanding environmental conditions. By analyzing the ratios of specific isotopes, variants of chemical elements, in bones and teeth, researchers can infer with surprising accuracy what kinds of food ancient people consumed, the climates they lived in, and even the types of water sources they drank from. For example, a high nitrogen isotope level might indicate a diet rich in meat or fish, while certain oxygen isotopes can reveal whether someone lived near the ocean or in a high-altitude area. Through such analysis, archaeologists gain insights into how ancient societies survived, what kind of resources they depended on, and how they adapted to changes in their environment over time. This information plays a crucial role in understanding how civilizations rose, thrived, or collapsed depending on their dietary choices and available resources. Perhaps one of the most thrilling and transformative developments in the field of archaeology is the increasing use of artificial intelligence and machine learning algorithms. These technologies are not merely tools, they are reshaping how archaeologists approach data. Traditional methods of archaeological investigation often involved painstaking manual sorting through vast quantities of information, pottery shards, ancient scripts, satellite images, and more. Now, with AI, the same data can be processed and analyzed in seconds. These intelligence systems can recognize patterns and draw correlations far faster and more accurately than any human ever could. AI can process satellite imagery to detect subtle signs of buried structures, locate potential archaeological sites, and even assess whether certain land formations are natural or man-made. This dramatically increases the efficiency of fieldwork, allowing researchers to focus their efforts more strategically. In a landmark project, an AI model was trained specifically to translate a long-lost written language, something that human researchers had been working on for decades without a breakthrough. By feeding it thousands of fragments of text alongside known translations from related languages, the AI was able to make educated guesses about unknown words and grammar rules. This led to astonishing revelations about the culture, religion, and administrative systems of an ancient civilization that had long remained mysterious. Such breakthroughs opened doors to entirely new chapters in human history that had been closed due to language barriers. Machine learning also plays a major role in artifact analysis. When a new object is unearthed, whether a piece of pottery, a coin, or a tool, it can be scanned and instantly compared with a massive global database of known artifacts. The AI can determine where it likely originated, what its purpose was, and which civilization created it. This has transformed what used to be a time-consuming process requiring the expertise of multiple specialists into something rapid, accurate, and accessible. The result is a more connected understanding of cultural development, trade networks, and historical timelines. The rise of these technologies is not without challenges and ethical considerations. As archaeologists embrace digital tools, they also face important questions. For instance, how can we ensure that technological advances do not lead to the exploitation or destruction of fragile heritage sites? Should every discovery be made public immediately, or are there cases where preservation should take priority over exposure? Additionally, there's the question of equity. How can these tools be shared globally so that countries with fewer resources are not left behind in this technological revolution? Archaeology must remain a science for all humanity, not just for those with the means to afford the latest tools. Moreover, with the growing digitization of historical data, concerns about data security, cultural ownership, and misinformation also arise. Who owns the digital scans of ancient manuscripts or the AI models trained on indigenous languages? These concerns must be addressed to ensure the ethical and respectful advancement of archaeological research. Despite these challenges, the integration of cutting-edge technologies continues to revolutionize archaeology in ways never imagined before. From LiDAR, light detection and ranging, systems capable of mapping hidden jungle cities, to ground-penetrating radar that detects underground ruins without any digging, to drone-based aerial photography and 3D scanning that allows for virtual reconstructions of ancient sites, each new innovation adds a valuable layer of understanding. DNA analysis, once used only in biology,